Okay, today we're actually going to get into filling in some angle proofs. It's going to follow much the same format as when we were working with segments. We're going to mark stuff in the picture. We're going to write out reasons. We're going to say which previous steps we looked at to get our reasons, all of the same things we've been doing before. So the first thing you're going to want to do is rip off the front page of your packet where you've got all of the different reasons we can use, the different theorems, the postulates, and the definitions. And we're going to follow the same two important steps from, or actually 3 important steps here that we followed when we did segment proofs. And the first thing was anything we knew right away, we would mark in the picture. So we are given PQR is a right angle. So first of all, I've got to know, how do I mark a right angle in the picture? So I go ahead and I put a box. Let's make that box a little nicer. Go ahead and make a box right there on PQR. That's pretty close, but not close enough. There we go. So that is a right angle. And then it says what we're trying to prove is that PQS and SQR are complementary angles. So that should make sense. If I look at my picture, I see that PQS and SQR together make that right angle. And complementary angles are angles that add up to 90. It's going to be really important that you are fluent in the terminology of this section. That means that you need to know what complementary means. You need to know what supplementary means. You need to know what a linear pair looks like, what vertical angles look like. That's why we learned those first. So if you need to draw some pictures of those again on your front page, or maybe somewhere so that you can refer back to them very quickly, that would be a good idea. All right, so our first statement, angle PQR is a right angle. That comes from a fairly obvious place. That is given. So we just write given there. Now our next statement asks us, how do we know that the measure of angle PQR is 90 degrees? So this either was already right away in the picture, which it wasn't. It wasn't there for us in the picture. Or it came from the previous step. So the previous step said it was a right angle. Now we want to say it's 90 degrees. So if you look at your front page there, you should see something that has to do with a right angle. You should see that the definition of a right angle lets you switch between it being a right angle and 90 degrees. So we say that this is the definition of, and then this is where it's nice to be able to abbreviate, right angle. Definition of a right angle. Says it's 90 degrees, and we looked at a previous step to do that. We looked back to step number 1. So I'll put that there. Now, my next statement, I read my next statement. It says measure of angle PQS. So it's always good to kind of match stuff up to the picture. Here's PQS right there. And measure of angle SQR. I'll pick a different color for what I'm doing right now. There's angle SQR. So those two angles together, right away you should be seeing something. That's 2 parts I put together. And now it says that's going to equal, whoa, that's way too big. That's going to equal the measure of angle PQR. Ooh, that's the whole thing. So if I do the 2 parts added together and I get the whole thing, that's what this statement says. How do we know that is true? Well, we know it's true just by looking at the picture that part plus part equals whole. That's called the angle addition postulate. And we're going to write down where we got that from. We didn't get it from looking at any of our previous steps. We got it straight from the picture, looking at the picture. Now next, it says measure of angle PQS plus measure of angle SQR equals 90. Now as we said, the angle addition postulate, that's the one that comes from the picture. Once we've done that, we're done from the picture. So this step here, this step that we're looking at right now, 4, came from one of these previous steps somehow, or some combination of previous steps. So what we've got to do is we've got to look for something in our previous steps that looks familiar. And what I notice first of all is that this here and this here, oh, it looks a lot like step 3. Actually, it looks, let's maybe look at all of step 3 and see what changed to get to step 4. Well, what I noticed changed is that now we don't have PQR. It looks like PQR became 90 degrees. Now, am I allowed to take out PQR and just put 90 degrees in its place? Oh, yes. If I look back here to step 2, I know that PQR, the measure of angle PQR, is 90 degrees. So if I know those things are equal, what that means, if I know those things are equal, that means that I can do a substitution. So I took the PQR out and I switched it out with 90. I'm just going over this arrow here showing that I'm doing that substitution. So let's go ahead and write that in. Substitution. Substitution. And which previous steps did we use to make that substitution? We used 2 and 3. Now finally, we want to say that PQS and SQR are complementary, because remember, just like before, we are not done until what it says right here to prove, until that is our final step. And so now we're finally saying that they are complementary. Now this probably came from a previous step. And if I look at my front page there, if I look about how I could say something is complementary, I know that things are complementary if they add up to 90. So that is just the definition of complementary angles. Angles are complementary if their sum is 90 degrees. And in the previous step right here, I'll circle it so we're all on the same boat here. This right here, we said the 2 angles add up to 90 degrees. Now we're saying those same 2 angles are complementary. And the way we go from one to the other there is just called the definition of complementary. So I'm going to abbreviate definition of complementary angles. And which previous step did we look at? We looked back to step 4. So if you were good at segment proofs, guess what? You're going to be pretty good at angle proofs. The only thing that we need to be able to do a little bit more now is remember the vocabulary, because we're going to have complementary, supplementary, linear pair, etc. All right, we're going to skip to number 3 now. So move your paper down to number 3. And let's go ahead and see what number 3 looks like. So number 3 says, first of all, 1 and 2, angle 1 and angle 2 form a right angle. I'm going to add that to my picture. So right angle with 1 and 2. And it says angle 1 plus angle 3 equals 90. Okay, and then it wants us to figure out that 2 has to be equal to 3. Well, let's talk about why this makes sense first of all. So 1 and 2 together, so this one and this one, we know that those add up to 90 because in the picture, they make a right angle, so they got to add up to 90. In our given, we know 1 and 3 add up to 90. So if 1 adds up to 90 when you pair it with 2, and 1 also adds up to 90 when you pair it with 3, then 2 and 3 have to be the same thing. Because when I add them to 1, I get 90 either way. So this seems like it makes sense. It seems like it should work out. Remember, talking it out, kind of thinking through the rationale, the reasoning at the beginning, super important, super helpful for making sense of these. All right, angle 1 and angle 2 form a right angle. That seems like that was given to us because it's written right up there, word for word, so we know exactly what that is given. Now, how do I know 1 and 2 are complementary? So this is where it's going to be good to have your chart in front of you, because on your chart, you might be tempted to say, oh, it's right angle, so maybe it's just definition of right angle. But if you look at definition of right angle is that a right angle is 90 degrees. And here we went from what? We went from a right angle to complementary. We didn't go from right angle to 90 degrees or 90 degrees to right angle. We went from a right angle to complementary. So when you look at your chart, do you see anything that says if 2 angles form a right angle, they are complementary? The complement theorem. I see it now. So you just have to have that chart in front of you. As you get more comfortable with using these, they will become much easier. So the complement theorem, that is statement number, or we looked back at statement number 1 to get here. Now, how do we know measure of angle 1 and measure of angle 3 equal 90? Well, I don't have it marked in my picture, I don't think it comes from any of my previous steps, because guess what? These previous steps here, those are all about 1 and 2. Now I say 1 plus 3 equals 90. Oh, look, that's the second half of my given that I haven't used yet. So this is given as well. And the reason that we do this in our proofs is because a lot of times what we do is we wrote down our first given here, and then we do anything we can do with that first given, which was down to here. Then we're kind of done with that first given. Now we're going to write down our second given right here and do anything we can do with our second given, which will be right here. And then we kind of combine the two things. We kind of combine our two results, our results from the first given, results from the second given, and that's what's going to give us finally some new information. So let's see what we can figure out from this second given right here. So I know they add up to 90. Now I want to say they're complementary. Okay, if you're looking at your chart, 90 degrees to complementary, complementary to 90 degrees. Yep, this is the definition of complementary. This is really important to have your chart with you, and you're going to be able to use it on your test just like before. Definition of complementary angles. And which previous step did we look at? We looked right before this at 3. Now I want to say 2 is congruent to 3. So supposedly I've got this in my previous information. I just have to combine my previous information. So here I said 1 and 2 are complementary. So 2 is complementary to 1. 3 is complementary to 1. So previously I said 2 is complementary to 1 and 3 is complementary to 1. So that means when you pair 2 up with 1, they add up to 90. When you pair 3 up with 1, they add up to 90. So if they are both complementary to angle 1, then they have to be the same. Because that means when you pair them up with angle 1, it doesn't matter whether you choose 2 or 3. They're both going to be complementary to angle 1. They're both going to add up to 90 degrees when you pair them up with angle 1. So if you look on your chart, you should see down near the bottom, it's called the congruent. Or actually, let's go ahead and use symbols whenever we can to make our lives easier. So the congruent complements. I always want to spell complements with an I. Whoops. Congruent complements theorem. In which previous steps did we combine here? We look back at those 2 steps where we knew 2 is complementary to 1, 3 is complementary to 1. That was step 2 and 4. All right, and that's it. That's a full proof right there. Let's do one more example together. So down to number 5. Number 5, we know angle RSU is congruent to angle VST. So remember, we're going to add this to our picture. Now we're talking about angles now. Segments, when we knew they were congruent, we would add tick marks on the segments. For angles, we do not want to add tick marks. We want to add arcs. So I'm going to zoom in here so I get my arcs right. So here is RSU. Here is VST. You can zoom back out now. So those 2 angles are congruent. And then it says, let's figure out why this makes sense. It says RSV, here's RSV, is going to end up being congruent to UST. Here's UST. So why are those going to be congruent? Well, let's just look at RSV. It's like 2 parts, right? It's the little one we mark congruent, RSU, and then it is, this angle here in green, this big one. What about UST? Well, UST is 2 parts as well. It's like one of those little ones we mark congruent and that angle there in green. So it looks like I'm doing like 2 parts together in each of them. And since we've got the congruent ones in each of them and then the one in green, it seems like they should end up being the same or congruent. So let's actually go through the steps and work that out. So first of all, I know angle RSU is congruent to VST. That was given right there in the given. Now I say measure of angle RSU is equal to measure of angle VST. So what did I do? This either came from the picture because it's angle addition postulate, but guess what? This does not look like part plus part equals whole. So guess what? It probably didn't come from the picture. However, it does look a lot like this previous step. Those are the worst arrows I've ever drawn, but you get the idea. It looks just like that, only now we have the measure of the angles are equal. So we changed from congruent to equal. And we have a reason on our front page that says that is, once again, just like it was with segments, that is the definition of congruent. Let's just change from congruent to equal or equal to congruent. And we looked at statement 1 for that. Now we have RSU plus USV equals RSV. Well, let's just see where those are. There's RSU right there. Oh gosh, my drawing is bad today. There's RSU, there's USV. So that kind of looks like two parts, RSU, USV. And then those equal what thing? Those equal RSV. So it's the two smaller angles inside of RSV add up to RSV. So it is the part plus the part equals the whole. So what is that again? That is the angle addition postulate. And where did I look to find that? I looked right in the picture. Now we've got VST plus USV equals UST. This is a good example of where trying something is a good idea. So I look at this and maybe I'm like, hey, this looks sort of like the line below. Sort of like the line above. It's two things added together equals something else. It looks like maybe this USV here stayed the same. So that's cool. So maybe we did a couple substitutions. Maybe I substituted RSU out and put VST in. Okay. Look, there, it says I can do that. It says up here I can do RSU to VST. Great, we did a substitution. Not quite, because what else changed? It says RSV became UST. Do we know RSV? Do we know up here that RSV and UST are equal so I can substitute those as well? No, I have not said that before. So we almost could say this is a substitution. It looks like we substituted one thing, but we didn't do a substitution on both of those things that happened. So we can't say substitution because that's not what happened here. We didn't do two substitutions, so we got to find something else. So how else do we get something that looks like this, where it has like an angle plus an angle plus an angle equals another angle? Well, let's see where these are in the picture. So VST, that first one, that's right here. Ooh, not even close. There's VST. And then USV, that's right here. Oh, those are kind of next to each other. It looks like a part plus a part. And then UST, the last one, oh, yep, that's the whole thing. So this is another part plus part equals whole. So it's another angle addition postulate. And as always, if I'm doing the angle addition postulate, that means I was looking at the picture. Now, we've done our part plus part equals whole for both kind of sets of angles in here. This next one probably came from somewhere else. So let's see if maybe this time this came from a previous line. So I look at this. And when I go back to match it up with a previous line, normally I'm going to start with ones that are closest to this. So I'm probably going to go back and see that this matches quite closely with step 4. If you were looking back and saying that, oh, our new line, step 5, also might have matched with step 3, that's a question mark, also might have matched with step 3, you're not wrong. It could be one or the other, but I always start with the one that's right above or closest above before moving farther back. So let's try that first. So what changed from step 4 to step 5? Well, VST is gone. And what is in its place? RSU. It looks like maybe I took out VST and substituted in RSU. Am I allowed to do that? Well, I look back at my previous steps and I look there in step 2. Oh yes, I know that their measures are equal. Once I know two things are equal, that's when I'm allowed to do a substitution with them. So this was a substitution. And which previous steps did we look at here? Well, we used the equation from step 4, and we used the things we knew were equal from step 2 to do the substitution. Now finally, we've got measure of angle RSV equals measure of angle UST. So let's figure out where that stuff came from. Measure of angle RSV. I've got to look back a ways to even find an RSV. Actually, I only see one of them even in this picture. So RSV there. Here's the only other RSV I see in a previous step. Okay, what about UST? Well, there I've got a little more freedom. There's a few more USTs. But once again, like I said, when I'm looking back, I'm going to look to the most recent one. So here's UST. Let's clean this up actually so we can really clearly see what's going on. So we had, like I said, UST matched up with this one right before it, and RSV matched up with this RSV. Now, how is this useful? Well, way back in step 3, I knew RSV equals all this stuff. And then in step 5, I knew UST equals all this stuff. What do we notice about these two in step 3 and step 5? They're the same, right? RSV equals all this stuff. UST equals all this same stuff. So if they're both equal to the same thing, now I want to say they're equal to each other. Hopefully you're all yelling it out really loud and the sub is trying to tell you to calm down because he doesn't realize how excited you are that you know that this is the transitive property. The transitive property of equality. And which previous steps did we look at to get that? That was 3 and 5. I'm going to go over that one more time because the transitive property is the hardest one to find, but it is the most important. So I look back to where this RSV came from. I see the RSV up in 3. I look, oh, RSV was equal to all that stuff. I look back to where the UST came from. The UST is here in 5. It was equal to all that stuff. Guess what's true about all this stuff in 5 and all this stuff in 3? They're the same. So RSV is equal to this stuff up here. UST is equal to this same stuff. So if they're both equal to the same thing, now I want to say they're equal to each other. And when they're both equal to the same thing and you want to say they're equal to each other, that is always, always, always the transitive property. All right, and then final step. Final step, where did this final step come from? If we look right above, it should look very similar, only now we don't have equals anymore, we have congruent. And either way, switching from congruent to equal to congruent, it is always definition of congruence. And I looked right back at step 6. All right, with the rest of the time you have in class and anything you don't get done, you'll have to do over the weekend to bring back on Monday. I want you to do numbers 2, 4, and 6. Those are the ones we skipped. So we did 1, 3, and 5 right here in the practice section. I want you to try numbers 2, 4, and 6. You can work together. You can help each other out, but do those as best you can for Monday. Have a great weekend.